But the electromagnetic spectrum is huge. So RF exists a little higher in the frequency. And below that, you have ELF, BLF, HF, a lot of low frequencies. The fact that it's traveling down a wire makes it an antenna. And so it will radiate. And so I was tinkering around with my little magnetic field tester in our room, and I realized there's like really high magnetic fields. So the resultant power at a point in space is the summation of the antenna gain plus the power. So if you have two antennas that transmit 1 watt, and one has 10 dB of gain and the other one has 1 dB of gain, there's a lot more power coming out the 10 dB gain antenna because the resultant EIRIP is higher. Since the 5G antennas are much more highly directional, and their beamwidths are much finer, and they have many elements in the array, it's many dB higher in received power. Something I've realized since COVID was you talk to people and they don't have that much confidence in their medical doctor. They go to the doctor and the doctor gives them advice and they're like, I don't know if I really trust it. I've heard that so much. And maybe that's what it's going to take. Maybe it's going to take people doing like basic health research on their own to wake up from this and seeing that the big system doesn't really care about your health, right? It's there for profit.
This is Decentralized Radio. I'm Tristan.
And I'm Ryan.
The goal of this podcast is to help educate you on how to live your most optimal life. We will host industry expert guests to shed light on topics that matter.
We are not gurus, rather two individuals who have had to pave their own path to health and vitality, independent of the centralized systems that plague modern society.
All right, we are live here in Longmont, Colorado. I'm with Rob Rebich, my good friend. We're going to talk about a lot of cool things today, but more importantly, we're outside in the sun. It's, January 29th. It's pretty tropical here. Rob, how are we doing?
Good. Excited to be on your show, man. Been a long time coming.
Yeah, we have a lot to discuss. Rob is an expert in EMFs. Because he is 20 years of experience as a radio frequency engineer. Is that correct?
In radio frequency engineering, yes.
So we're going to dive deep into EMFs, 5G, Starlink, just Wi-Fi, everything. He's also an expert in Bitcoin, has been a Bitcoin hodler since 2013.
Long time ago.
So he's an OG, a Bitcoiner. And then he is also the owner, founder, operator of AUPA Bar, which is my favorite and most convenient, nutrient-dense, snack, food, pemmican bar-esque treat. So,
absolutely.
Where to begin? Okay, so how did you become kind of a sovereign individual? Maybe what was your storyline there? And did that, when you were working as an engineer, did that kind of make you think of the, potential health effects of electromagnetic radiation? I guess walk us through the beginning years of Rob as kind of like questioning the system and centralized authority.
Absolutely. So I grew up as a young boy with a father who tore apart motorcycle engines. He was a mechanic. So while I was out there watching my dad do that, my dad would go to like Goodwill or some ARC place and get me a old VCR, and I'd take that thing apart and then I'd stick it back together. And that's kind of where I really got into electronics. My uncle was also an electrical engineer, so I had that other sort of role model on my side. And I knew what I wanted to do since I was in high school. And so when college came around, I knew exactly where I wanted to go, and I went straight into electrical engineering. And I remember from being a little boy, I always was so curious about the phenomena of light, because I would look around at all the phenomena happening around me, and I thought light was the most intense, the most unknown thing. It was absolutely fascinating to me. And so I knew exactly, after I was done with my general bachelor's degree, I went into electromagnetics and focused in on electromagnetic theory. And that brought me to Boulder, Colorado. And that's where I worked at a defense contractor here for over 10 years. And during that time, I also got into Dave Ramsey about 2010-ish, up to 2014-ish, when I had a lot of student loans to pay off. So at this point, I wound up with a pretty good engineering salary, and I really wanted to pay off my loan because I hated debt. And at that time, this was kind of after 2008, and I didn't really have any stake in the game in 2008. So I really didn't lose anything, but it certainly woke me up to watching parents lose stuff and kind of woke me up to the whole monetary system. So in that time frame, I became really into gold and silver, but I just saw the problems with gold and silver. They're not perfect. I mean, you have paper gold and silver that the banks make and inflate, and they trade paper gold and silver, inflate the supply, and you have these IOUs. There's so many problems with it. And I was literally just waiting for Bitcoin to come around. I didn't know anything about it. I had no idea it was invented at that time, but in my mind, I was searching for it. And so I was purchasing a private internet access subscription on privateinternetaccess.com. And I was at the point where I was paying for the credit with a credit card. And I just thought, this is absurd. Why would you buy a privacy tool and then dox yourself with a credit card immediately? Because with a credit card, you send your first name, last name, and with that comes all of your information. And, I saw that little orange tilted B symbol and I didn't recognize it. And so I went to Google and typed Bitcoin. I stumbled across the white paper. And with my background in science, technology, computer networking, all these things, monetary theory, it just snapped instantly. Like, I didn't need the 10,000 hours to know Bitcoin was it. I knew right away it was it. And from that point on, I became obsessed with Bitcoin, and it kind of took over my life for about 10 years as I, kind of became my own version of Bitcoin Jesus in my community, like my work and my family, and after about 10 years, I realized I couldn't get that many people interested in it. And I think that's a common story. And so for the last, 5, 6, 7 years, I've been pretty quiet about it, and I just keep to myself, and I'm still a Bitcoiner. But in terms of electromagnetic theory, I was obsessed with the phenomena of light. And I was just blown away that James Clerk Maxwell came around and summarized light into 4 equations. And so I really obsessed over those 4 equations, and you could spend a lifetime obsessing over it and not even fully understand it. It is a very complicated subject because we live in a fully electromagnetic world. Our bodies are electromagnetic. Everything is electromagnetic. And so when I got into working, I wanted to do stuff for space and like stuff to push humanity forward. But unfortunately, the money is in the military. And so pretty much the only job I could really find specializing in EM theory was with the military contractor. And so for the next 10 years, I steered away from weaponry. I refused to work on any kind of weapon systems. And I was like the only person, the old weirdo, who wouldn't work on weapon systems because it was just crossed the moral boundary for me. So I specialized in defense systems like electronic jamming and electronic warfare, things that would save military personnel, and communication systems. And so I've designed an antenna for every platform you can think of, land, air, sea, and I've even done stuff for space, but it's never made it up to space. So I have a huge experience in onboard communication systems and jamming systems, all the way down from high frequency all the way up to, higher upper bands, KU, KA, and even higher. So I've done a lot of stuff with that. Through my years at my old company, I created a new technology in active electronic steering arrays, AESAs, and I got a patent for that. So
it's just such a perfect, bridge between us, like two electrical engineers who are really into EMFs and their potential effects on our health, to Bitcoiners, to you could call meatheads, really big in regenerative agriculture, locally sourced meat. I mean, it's incredible. And yeah, even just staying here in your property, you got a nice plot of land, some chickens running around. We're outside, and it's so great. I'm so excited. So let's dive in maybe first to the EMF stuff. And I want to just ask, I think I asked you this yesterday, is when did it start to click for you that, the things you're working on and the things we're just surrounded by completely in terms of radio frequencies may actually be detrimental to our health?
Honestly, it wasn't until about 10 years into my career. I mean, I worked in a facility, a laboratory where there's, 10 to 15 EMF type projects blasting in a building all day long. And I spent all day long in there. And surprisingly, I had 2 children already. So I didn't get affected that bad. But it was when I talk about falling down 2 rabbit holes. There's the money rabbit hole, and then there's the food and health rabbit hole. And I didn't fall down the food and health rabbit hole till later. I mean, I've always been like a healthy person, quote, but I didn't really understand the intricacies of it until much later on. And then, with my wife being pregnant and her concerns, her asking me questions about Wi-Fi and having tablets on your belly, it really opened my eyes to like, wow, this is something that there's a lot of problems with people's health these days, and no one knows the answer to them, but the answers seem obvious. And EMFs, just because they're non-ionizing doesn't mean they're perfectly harmless. There's more to the story here. And there's a lot more to the story. And there's a lot of things we have to uncover and figure out. And so that's when I kind of dove down that rabbit hole.
And did you, just think of it logically? Like, how did you build upon that? Just, speaking with colleagues, like, what were great resources and what was it like? Yeah, potentially talking to coworkers and other people. Because what I've found is that, people who know the technology really well have no consideration that could be possibly harmful to our health. Like you said, it's non-ionizing. I get messages every day about this. It's non-ionizing. There's only a thermal effect. And yeah, there's almost no engineers who actually understand the biological effect. But then the researchers or the folks who are into the biology piece, they don't know enough about the technical piece. So that's why, I'm so excited to talk to you, and that's why I send you voice notes all the time, asking questions, and it's fun. But how was that process for you?
I was met with the same type of experience. I mean, I worked around 150 people in my company, and I'd say there's up to 50 engineers. And I was continuously dismissed about Bitcoin, and I wasn't dismissed about the EMFs because I didn't engage in those kind of topics. But generally speaking, we were all taught that it's non-ionizing radiation and it's completely harmless, right? It's not ionizing. It doesn't go through your DNA and break it apart and bust everything up and kill you fast. But, deep down, I always knew, watching the proliferation of Wi-Fi and wireless technology, it just hit a breaking point for me where I was looking around and there's 6 Bluetooth devices in my kid's room. And that was the breaking point for me. And so that was the time. It was really my kids that drove this, because I wanted to exercise a precautionary principle. On one hand, I don't exactly know all the biological effects of EMFs, but I know that they're not zero. And so I don't want to have my children as experiments in this kind of game.
Hey, friend. Thanks for listening. If you really enjoy this podcast, it would be really appreciated if you left us a 5-star review on Spotify, Apple, or subscribe to our content on YouTube. This helps us get to a larger reach and a larger audience to spread this wonderful free education.
Yeah. And I mean, it's so important, right? Because it's we don't even know. You could read all the research studies and you can pick them apart. Maybe they're not perfect. Maybe they're not on humans. We don't have enough data, but to me, it warrants enough skepticism to warrant caution, right? And there's simple things that you can do. And it seems like you've obviously implemented a lot of these things in your daily life. Did you notice a change in personal vitality by using technology differently? And kind of what were some of the first changes that you made in your day-to-day life and how you use the internet, how you use technology?
So kind of our biggest changes that are pretty much predominantly our only changes was we kind of ditched Wi-Fi. I realized I don't need Wi-Fi. And secondarily, I used wired Ethernet everywhere that I could. And I still have a cell phone. I don't not have a cell phone, but my wife and I exercise airplane mode like no other. We get on our phones, use them for a minute, and then turn on airplane mode. The biggest thing I realized is that it kept me from just mindlessly being on the internet all the time and checking my phone on this really periodic, frequent basis throughout the day, because I knew that it was in airplane mode. And at the beginning, we would only use our phones connected via USB-C or Lightning adapters to Ethernet. We wouldn't even use the Wi-Fi for a little while. Now we kind of use it strategically. And I really think that's the good balance here, is you don't have to have none, as there's a good balance. And it's really this proximity to the biological being under study that is important. You don't want to have the phone right up against your testicles. You don't want to have it up against your head. You don't want to, if you're a woman, you want to place it in your breast right here. Just keep the thing away from your body. I mean, even if you go into your iPhone under general settings, you can find the disclaimer that talks about RF exposure, right? They're not even denying it. So, and I believe, someone have to fact check me on this, but I believe there's some nomenclature, some talk about even keeping a spacing from your body. You're not even.
There is, yeah. at least an iPhone, because I have this in the EMF course, is that 5 millimeter distance is what they recommend. They say always use speakerphone or hands-free or headphones.
Headset or something.
Never hold directly against your body.
Right. But yet you look around and most people are just having it jammed against their phone or have a little Bluetooth thing or, even the Bluetooth music. So to answer your question, I think I feel like everyone kind of feels this when your life is over technologified. It's a BS word, but when you have too much technology, you just don't, there's something wrong with it. And when you remove a lot of it, which this low EMF route, the side effect of it is you kind of remove a lot of these things and it's just liberating. It's free. I mean, it's really great for the kids. Kids don't belong on their games for hours and hours a day. Right now we have games for our kids and we limit them for 1 hour in the day. And usually what happens is they'll chew through that hour at like 11 p.m. or 11 a.m. and by noon, we're outside the rest of the day, if it's nice.
Yeah, I think, that's the way to raise children. There's too many digital babysitters nowadays. And once you give in, that dopamine reward system is just so like hardwired for them to want it more and more and more. And, they're getting hit by everything from, RF to blue light to low power frequencies. It's so scary. And we know that their biology is way more susceptible. So maybe we get into some of the technical details now, because that's what's really fun and your expertise is really is maybe we start with how are radio frequencies different from natural frequencies, say, coming from the sunlight? And why do you think this is like a problem? And getting into kind of all the aspects of it and just the nature of really an RF wave. And then we could talk about the difference between Wi-Fi and 4G and then 5G and future things that are also really fun.
Right. So the RFs and, general EMFs that we're exposed to, they're engineered signals. They're very polarized, and they're intentionally designed like they are. They're pulsed. So being pulsed is a really big problem because nature doesn't really pulse signals like that. You can probably go into the more biological effects because I'm not as aware of those, but it's another thing is the power density. We're seeing power levels that the human body has never really experienced. In terms of the ones that are native EMFs, our biology has adapted to those kind of fields and structures for, a long time. These non-native EMFs, the RFs, which are in 800 megahertz and up, are pretty non-native, and we didn't adapt to them, and they've really been a flash in the pan. I mean, when did Wi-Fi spring out of existence? In the mid-90s or 2000s, it grew really big.
Yeah, it's all relatively new, right? So maybe my question is, maybe you could explain polarization a little bit, and then why are they pulsed, and why do we have to have such an alien wave compared to what we're naturally getting that's, non-continuous, it's very coherent, very polarized? Like, what is the reason behind this from a technology perspective or design perspective?
Well, I think it's more of like a signal processing perspective. You have to have these type of signals so they can travel the distance and relay the data. What was the other question?
Just explaining polarization.
So polarization is the alignment of the electric field. It's defined by the electric field. And so an electromagnetic wave has an electric component and a magnetic component that are transverse. They're orthogonal to each other, 90 degrees separated. And so the polarization is defined by the electric field, and it can be linear, which linear encompasses vertical, horizontal, or any vertical angle between, like it could be slant. And then there's elliptically polarized waves. And a special case of an ellipse is a circle. So you hear circular polarization. So truly it's elliptically polarized. That's when the electric field rotates as it's moving in space along its direction of propagation. And so the way an antenna works is if you transmit a signal with, say, a vertically polarized electromagnetic field, you have to have a vertically polarized antenna to receive it. If you have a 45-degree slant antenna, you will receive a portion of that signal. If you have a horizontally positioned antenna, you will receive 0% of that signal. It's completely orthogonal to the direction of propagation. So you have to match the transmitter receiver of an antenna system and match their polarizations.
Yeah, that's something recently I kind of discovered and realized as well. And that kind of sunlight is unpolarized, or which basically means it's kind of random, right? There's
Say
no.
that's random. I think it'll be always polarized at some given point. But if you take a vertically polarized wave, if it's perfectly man-made, vertically polarized, and it reflects off something, well, it changes polarization as it's reflected. So when waves propagate through, say, like foliage on a tree, that polarization goes from a pure polarization to it scatters and it changes polarization. So as electromagnetic waves travel through anything but a vacuum, when they hit materials, they start depolarizing and become random. And so I believe the sunlight is quite random in polarization.
Yeah, it's just another component to it. And really the takeaway for people is to understand that these are very engineered waveforms. They're not really close to what we would naturally be programmed biologically to taking as an input from sunlight. And the pulse nature of it is really, a problem. I think probably the largest problem, because these are pretty high powered pulses. And from my understanding, really the radio frequency before technology that we would have been exposed to is pretty much zero in comparison. So how have you, well, maybe we get back to the home internet, right? Because that's something I've recently hardwired. And even with Wi-Fi ongoing in my house, the way I think about it is you're still, say you even have a Wi-Fi network, but if you're hardwiring the laptop or the computer that you're using, even with an ongoing Wi-Fi network, it's a benefit because you're, removing the transceiver receiver. Maybe you could talk a little bit more about that, because distance is always, the most important thing.
Yeah, so I'd say it's kind of a three major areas. So if you still stay on Wi-Fi, one of the biggest things is the separation distance. Electromagnetic fields decay really rapidly. They decay by the square of the distance, so they decay exponentially. So if you're really close to a transmitter, say your Wi-Fi router, say you sleep with it with a foot away from your head at bed, that's not good. But if you move that 15 feet away, you're talking about like 10,000, 50,000x in reduction in that electric field. I just made those numbers up, but I would bet it's in a huge magnitude like that. So you're talking about just moving it 15 feet away, you're getting orders of magnitude reduction in that strength, which is a huge deal. So general rule number one, keep them away from you. Whatever biological structure it is, primarily yourself or your kids or your family, just keep them away. That's a huge start. That reduces the field strength dramatically. The second approach is to just stop using the Wi-Fi altogether or your Bluetooth. Wi-Fi is pretty easy because you can just get a Cat 5 or a Cat 6 or Cat 7, and you can remove that wireless connection. And they make all sorts of little adapter dongles that go to USB-C to Lightning to just USB-A, all of them. You can get anything that converts an Ethernet to whatever you're using. And that will remove all the wireless components, and there's no transmitters anymore. Bluetooth is different because you can't really hardwire Bluetooth devices, right? There's no like wired replacement. The idea is just get rid of them. Like you can just have a simpler life without all these Bluetooth devices. Bluetooth sucks anyways. I'm sure we've all had headache moments pairing Bluetooth devices. And if you want to go the extra mile, the third prong of this idea is you need to think about the currents. So there's currents that are generated on all these devices. Like say your laptop, you're sitting in your bed, it has a metal chassis to it. And there's all sorts of electromagnetic components inside of it, sourcing fields. There's outside fields that are coupling to it. And so even if you're hardwired and there's not a proper ground that goes all the way to Earth, well, then you're a floating potential. And, who knows what it does at that point. It raises your body voltage. It's just not the full way. So to go the full way, you need to have a physical ground that goes from your chassis through your Ethernet all the way to Earth ground. And Cat 5 will not work for this. Cat 5 is unshielded. It does not have any metallic barrier on the outside that shields the cable. To do this properly, you have to step into Cat 6 or Cat 7 or higher. You'll notice when you look at the connecting end of an Ethernet cable, if it's just plastic, that's Cat 5. Or it could be Cat 6 or 7 improperly connected. But if you find one that has ground around it, a metal connector, it's likely Cat 6 or Cat 7. And you just need to read the text on the wire and it'll tell you. But that's how you need to transfer ground, is through a properly grounded Ethernet, such as Cat 6, Cat 7.
Yeah, it's under discussed. I think it's a benefit regardless to hardwire because, right, you're moving that transmitter and receiver from being like a foot away from you at all times to kind of just having whatever exposure, the average exposure that may be a lot further away, right? So the laptop itself, when it's on airplane mode, is not transmitting and receiving those RF signals, right?
Right. Correct. I believe airplane mode completely shuts. For a laptop, shuts down the Bluetooth and the Wi-Fi. I think there's more nuances to mobile devices that even if you shut off data and Bluetooth, there still could be SMS transmitting. So airplane mode, I believe, kills even SMS.
Yeah. To me, that was kind of realization. It's like, if you have roommates or tenants or something, even if you have like a Wi-Fi network on, hardwiring your main technology is still going to be a benefit because then you're just eliminating that. And again, that's where you're spending all your time in close proximity. So for me, my phone's always on airplane mode too. I mean, even if you're at home, like if you have Wi-Fi and cellular data on at the same time, we measured it yesterday. It's an additive effect. You're getting blasted by 2.4 gigahertz and then whatever, 800 megahertz, gigahertz, or whatever the frequency is. So when you're using your phone and you're at home, even if you haven't hardwired your internet yet, just keep it on airplane mode and only have the Wi-Fi on. And then if you need to keep the Wi-Fi on for some reason, just hardwire your computer in, and you're getting rid of that transmitting and receiving signal quite a bit. And then what I always say, of course, is the sleep sanctuary is so massive for creating an ability for our body to kind of repair and restore. But you had an interesting case study as well where you replaced the copper pipes, a piece of the copper pipes in your house with PEX to reduce the magnetic field exposure. So
right, yeah, I was walking around. So I was first looking at the RF signals, like things that come from our personal devices. But the electromagnetic spectrum is huge. So RF exists a little higher in the frequency, and below that you have ELF, BLF, HF, a lot of low frequencies. So for instance, your AC mains power that comes into your house is a 60 hertz alternating signal. So the fact that it's traveling down a wire makes it an antenna. And so it will radiate. And so I was tinkering around with my little magnetic field tester in our room, and I realized there's like really high magnetic fields. Then I started following the wires. Our main panel breaker went in the wall right next to where we slept, and it had a dozen Romex wires in it that feed all sorts of things in our house and property. And that ground from the panel was connected right to the water pipe, copper water pipe coming into our property, which provides a really good ground. But somehow, I'm not sure of the exact physics of what was happening because it's very complicated. Somehow these wires and this ground was exciting my whole copper system in my house. And if you can just imagine, so take away your house and leave your copper pipe standing, and it comes up from the ground and it has these 90-degree elbows, and it's like this fractal pattern. It's like a little tree that stands up in your house if you take all the walls, and that's an antenna. And so that thing was radiating, and I could prove it because as I got my meter really close to it, it would increase the signal strength of the magnetic field, the nanoteslas, and as I pulled it away, it would die off pretty quickly. But usually, if those things are far away from you, they're not a big deal. But this one is pretty close to us. So what I did was I cut out the copper pipe from where it's coming in the house, and I put about a 15-foot section of PEX and just patch it in there. And it completely changed these readings. Like I think it was about a 10x reduction or something in several areas of concern.
I think it was even more based on whatever you showed me yesterday. It was like 20 to 30x. It's kind of a catch-22, folks, right? Because you'd probably rather use copper for reducing plastic, but we live in this EMF-laden world that anything that's metal that is going to be able to hold on to charge, and especially if it could be ferromagnetic like steel or potentially copper, it's tough. And that's where the nuances come into play with things like grounding and grounding sheets. We won't dive deep into that, but there's really a number one recommendation for everyone that I give is you need to address your EMF environment first And then everything else can kind of fall in line after that, because, people even, say don't use metal spoons and metal cups, because that's all taking in that charge from the non-native EMFs, and then you're putting that in your water, and you're drinking the water or your tea or whatever you're mixing with, and that could change the frequency or just the energy that you're consuming. And maybe this gets a little woo-woo, but it's not, because we know it's science.
But like you said, the spoon and these other things are like really secondary or tertiary effects. You really want to focus on that. First, the primary thing is this EMF environment, like the Wi-Fi, the Bluetooth, and like baby monitors and Wi-Fi cameras. And if you have kids, you really probably need to prioritize your kids before yourself. So like we have a sleep sanctuary where our kids go to bed, and I've measured it, and it's a very low EMF environment. It's not zero, because you can't get it zero. We have neighbors. We have a cell tower half a mile away. But we prioritize our kids. And, there's, like you said, they have more water content. They're smaller people. These industry standard SAR ratings are meant for like a bigger like dude, not for little tiny kids. And you know what? You love your children. Why not exercise the precautionary principle? Even if you don't know, why not exercise something safe so they don't end up being an experiment?
Yeah, it's spot on. Let's get into the fun stuff now, which is really your area of expertise, is like the technology of what's coming, or what we have here with 5G, and what may be to come, Starlink, vehicles. Talked about a lot in the past, I don't know how long I've been here, 20 hours, but no, not even 24 hours. But it's a big question I get. I've written about 5G, but you know a lot more than I do. Why is 5G so fundamentally different from an engineering perspective from 4G? And how is that, warranting more concern from someone like yourself?
Sure, yeah. Yeah, so up to, first generations, up to 3G, 4G, those are all relatively the same kind of base station build. So 4G essentially relies on pretty large cells, and these towers are pretty much single antennas. There's several up there, but the antenna itself is not an array. It is like a single antenna that kind of blasts out a broad beam of energy, and it kind of covers everything, covers this whole region within the cell. So it's directional, but it's more omnidirectional than what 5G is getting into. So yeah, so 4G kind of blasts out a lot of energy everywhere. Stepping into 5G, this is when you get into phased arrays. So they have designed panels with, a couple hundred little antennas on them that they all work in unison to steer a beam digitally without any moving parts. They use electronics. They use phase to feed each element with a different phase, so it can be steered azimuthally up in elevation. Azimuthally means side to side. Elevation is obvious up and down, and you can get a compound of those two. So they can steer this beam anywhere in the forward direction of this phased array antenna. Now, with this comes much higher gain and I think much more transmit power. And so and the frequency goes up. And we know, we've talked about that, there's about 3 different frequency bands in 5G. And really, they've only been doing this low band. And what did we say the low band was?
Low, they've been doing mid-band too, from my research, but low band is kind of the same as 4G, I think, like 800 megahertz, maybe around a gigahertz. Mid-band is like 3 to 5 gigahertz, and I think they're in that like 3.5 gig range. So that is increasing the mid-band usage, but I think for most people, it's probably still in low band today.
Right. So with 5G, you have these much finer resolution of cells they have to install, because to get this data rate, you have to put base stations much more frequently to provide you these high speeds. So the disadvantage of now you have this much higher gain, higher power antenna beaming around all the time. But there is a hidden advantage that if you don't have any 5G devices connecting, that beam doesn't have a reason to steer towards your area. So that could be the benefit of it. But, if you're living in a highly populated, highly dense area with like a smart city, I don't think you can hide from it. I think even if those beams are pointed somewhere else, you're going to be close to them. And there's so many more of these stations. They're like microgrids. I mean, if you look now, how many cell towers do you see? I see like one, but with 5G, you're probably going to see them every couple blocks.
Yeah, and you see that in the cities already, all these repeater towers kind of being installed. And to me, the concern is, yeah, when you get into like that, the beamforming, because as you said, it's higher power. And even though it's like more targeted and it might be easily avoidable if, you don't live in a city. And maybe here's a quick question. If you go and turn like 5G off in your cellular data settings, will that never really transmit to your phone then because you turned off the receiver? Obviously, it's on airplane mode and you're just using Wi-Fi. I'd imagine that's the case. But pretty much, if you're eliminating the ability for it to hit your phone, then you're kind of protected on a individual basis.
Right. If you don't give it a receiving endpoint, then there's no reason this array is going to steer its beam to you. But if you're a foot away from your friend who has it on, then that doesn't really do anything. But, I'm just kind of making up numbers here. If you're 20 feet away, 50 feet away, you're probably good. So yeah, I would believe that if you disable the 5G functionality via software on your phone, you should be much better off. But I would bet that doesn't guarantee you're not going to get little pulse signals here and there just doing some kind of communication. But I'd say generally speaking, that's the way to go.
Is that also like what is the beam angle of something from 5G? I don't know if we talked about that yesterday. Is it also like 2 degrees or something really, really low? Or is it probably a little bit wider?
My gut, I don't know exactly because a lot of these kind of specs are kept secret by the manufacturers. But I bet it's quite narrow, definitely less than 10 degrees. Yeah, I'd probably say less than 10 degrees.
So I think about it is like, yeah, like Rob said, it's like this thing is kind of just very targeted. It's following you around via beam steering. And then it's it needs the receiver though in order to do that. So if you give that or if you turn that off and you don't give it the opportunity to do that, you can easier avoid it. However, if you're like in downtown Denver here or downtown Austin or wherever, I mean, think of how many people have 5G enabled on. Like you're just going to be, blasted from every which way direction. And then it's higher power. Like how much higher power are we talking compared to like an omnidirectional, 4G signal, do you think? Maybe estimate.
This podcast is brought to you by our lead sponsor, EMRtek. EMRtek manufactures high-quality, high-powered red light therapy devices. In my opinion, red and infrared light are two of the biggest nutrient deficiencies in our modern society due to our indoor lifestyles. Red light therapy devices, like the ones from EMRtek, can help combat that by providing high-powered red light while being indoors. I personally use mine every morning and every evening. Red and near infrared light is extremely beneficial for energy production in our body because it boosts mitochondrial function and penetrates deep into the cell. It is also extremely beneficial for skin health, eye health, as well as our circadian rhythms. And this is actually pretty much why I bought everyone in my family an EMRtek red light therapy device for Christmas. EMRtek panels are low flicker, low EMF, and use targeted wavelengths such as 830 and 630 nanometers, amongst others, to get extremely effective results. For more information, go to emrtek.com and use our code DRadio10 for 10% off your order. That's emrtek.com with our code DRadio, DRADIO 10 to save at checkout.
Well, so the numbers we talk about as engineers is called EIRP. It's equivalent isotropic radiated power. And that takes into term the actual raw power that's being transmitted from the antenna. And then that also takes account for the gain. So the resultant power at a point in space is the summation of the antenna gain plus the power. So if you have two antennas that transmit 1 watt and one has 10 dB of gain and the other one has 1 dB of gain, there's a lot more power coming out the 10 dB gain antenna because the resultant EIRP is higher. So since the 5G antennas are much more highly directional and their beamwidths are much finer and they have many elements in the array, it's many dB higher in received power. I don't know the exact transmit power of them, but it is far more than 4G.
And then imagine you have like, you're at a football game or something and there's, 1,000 people around you. That's got to be like, hundreds of times the exposure compared to just being in a 4G world.
Oh, really. Yeah. When you go to a big stadium, a lot of time you'll just look up around the upper rim of the stadium and you'll see all these white panels, and those are all massive MIMO, like multiple input, multiple output base stations. And that's there because they have to serve up tens of thousands of people in a little small area, and they can do it. But back to like being in a city and you have your 5G disabled, you don't know if there's someone, if you're between someone and the transmitter. So even if you have yours off, there could be someone like behind you in a wall that's using it, and it kind of radiates right through you anyways. But the thing about 5G is it's highly susceptible to physical things, physical objects. In a vacuum, it's awesome. But once you introduce like city structures like trees and windows and other objects, the signal deteriorates very rapidly because of its high frequency.
Yeah, and that gets into the millimeter wave component, the high band. So we're talking the high band is the millimeter wave area of 5G. This is the one that, kind of everyone was freaking out about for a long time. And the good thing is right now in 2024 here, it's not used.
I've never measured the high band here.
Yeah, Rob has a meter from Safe and Sound, and we tried it out yesterday, and it's picking up nothing. Maybe if I've heard they've tested pulses in downtown cities, it's going to take time. And that's like 20 to 40 gigahertz, I think. Yeah, in that range. But yeah, maybe talk about the atmospheric losses, the engineering challenges with that a little bit more, because it's almost like a catch-22. It's kind of funny, but I see it as, again, a good thing, because like if you're not in the city, you're really never going to have to worry about it too much.
Right. And so first I want to explain to why we use high frequency is that, so increasing frequency is proportional to data rate. So if you want more data per given time, you need to go higher frequency because it's oscillating much faster. Like our cell phones running in the 900 megahertz range, they get pretty good, but they're lower data rate. And that's pretty much the push to go to higher frequency like 5G. And that is also proportional to the number of devices on that network. So there's so many more devices that are connecting that it's swamping out, the 4G is not going to be able to handle it. So that is kind of the push to do this. But as Tristan was saying, there's a lot of atmospheric challenges and just challenges to rolling out 5G. You have to have very precise antennas. These things are not simple. They're multi-layer PCBs with a lot of engineering into them. Since they're at such high frequencies, or when the higher bands roll out in the 20 to 40 gigahertz, those kind of signals degrade really rapidly. And if you just have a point-to-point link, I think you can get that 5G high-speed data for I think I read a block or something. But if you are, between another human being or a tree or some kind of bush or other obstacles, it really degrades it fast, and you're not going to get those high speeds. You're going to be probably pulled down to the 4G speeds. And then distance, right? If you're outside like a couple blocks, you're going to already be down way below those advertised 5G speeds. That is why they have to put another base station the next block. And don't forget that these beams, they don't just point and then give you data. They're continuously steering. As you move, they're following you and steering everywhere you go continuously. And so they don't just point and shoot, they're continuous.
Yeah, it's kind of scary. I feel like that's why they're trying to shepherd everyone into the city as well. And that comes back to like the fiat economy and trying to prop all this up, because it's a big, like telecom is investing big into millimeter waves. And it's kind of like been a disappointment for so far.
I feel like I would have seen a bigger rollout in the high band by now, but I haven't really seen anything.
So we have more time, folks, to get out of the cities and like become self-sovereign, buy Bitcoin and be able to build your homestead. But it's coming for us, and it's coming in a lot of which ways, directions, and not just with cell phone. One thing that we've talked about that Rob was brilliant enough to do some calculations on is Starlink. And that's one and I'll give you a little note sheet back here, is I get a lot of questions about Starlink because, it's convenient for a lot of people with no internet. But just reading into it, they're using higher frequency bands like KU, KA. As you mentioned, you have experience with these bands. There's just multifaceted, right? Like they're just 10,000 plus satellites now in low Earth orbit. That's a concern for a lot of people in general. And then my concern is just, are we being irradiated with beams that we're not consenting to? And let's talk about Starlink a little bit and what you have uncovered, what your thoughts are.
Right. You mentioned that it's convenient, but I'd say that in a lot of cases, it's like life-changing. So the benefit of something like Starlink is you can go move out and get out of the city, and you can connect to the internet and do all your things. You could have a remote job and be working out in the middle of nowhere where you couldn't have done that before. So it is a game changer for many people. But yeah, so these constellations, these Starlink constellations, they're little shoebox size antennas. They're like literally the size of a shoebox, and there's tens of thousands of them. Or I think Starlink was aiming at 12,000, and they're not the only constellation. There's going to be more in the future. So you're going to have like 20, 30, 50,000 of these things in the near future, zooming around 350 miles above the Earth's surface, which is considered low Earth orbit. And that's about 60 times faster speeds than you get from a geosynchronous satellite that sits positioned in space. So that's way away from Earth. These are really close to Earth. Even though it's 350 miles, that's still considered very close. But yeah, they have a phased array antenna on them. And the receiver on the base station on the ground also has a phased array. And so they communicate via very narrow beams, little pencil beams. They're not indiscriminately blasting radiation out everywhere. They have to be very precise, just like 5G, how they steer these beams and track it continuously across the sky. I think a Starlink satellite, you stay connected to it for something like 5 minutes as it moves through the sky, and then another one comes over and you hit that one and you keep reconnecting. And that's seamless, and you just keep reconnecting. But this is done through phased array technology, just like 5G antennas. So I was doing some rough order of magnitude calculations, right? These are ROM calculations. These are just ballpark. If you really want real numbers and you want to consider all the details of space and the atmosphere, these calculations get really complicated, and you get tied up in the details. So these are just rough order numbers. So for a low Earth orbit Starlink satellite hovering about 350 miles above the Earth's surface, I couldn't find what the beam width of these transmitters are. I don't think they release this information publicly, but from my design experience in my career, I would guess about 2-degree beam width. And when you talk about beam width, that means it's from the center of the beam halfway down until you lose half the power on the edge of the beam. So it's called the 3 dB half power beam width. And so I'm going to guess it's 2 degrees. For my calculation, I did 1 degree. So that's even better. So if you have a Starlink satellite transmitting a 1-degree beam from 350 miles up above the Earth's surface, that will create approximately a 70-mile diameter circle on the Earth's surface to where that beam is illuminating. So it's not just illuminating your Starlink receiver, you're illuminating a 70-mile diameter around you. Another calculation I did was to get that to 10-mile diameter, you'd have to have a 0.01 degree beam, which they're not doing that. I would say at the best scenario, it's a 1-degree beam, but probably 2-degree beam. So if you move up to 2-degree beams, you're talking about like over 100-mile diameter in radius, or 100-mile diameter circle. Now, I don't know what the transmitting power of the Starlinks are, but I had a pretty good estimate through some research, and I picked 100 watts of transmit power. So 100 watts of transmit power at a 1-degree beam width results in a 0.01 microwatt per meter squared density in that 70-mile diameter. So 0.01 microwatts per meter squared. Now, that number doesn't mean anything unless you compare it to something else. So I went and found, I looked at my home router and my old Wi-Fi system, and I did some calculations, and I came up with that where I was at in my house, I estimated about my Wi-Fi produced about 100 microwatts per meter squared. So now you're talking about 10,000 times lower from 100 to 0.01. So that's a lot of talk. What that means is that while the Starlink satellite is illuminating a huge area on the ground, your neighbors and everything else in there, the overall power density is quite minimal compared to what your Wi-Fi does. So my gut feeling would be that and this is for one beam pointing down. My gut feeling would be that the Starlink satellite, the density coming down from space is not the biggest deal. But now if you have 100 people in this small grid, you have a lot more power. So that amps it up quite a bit.
So it is like an additive effect. You think then because 100 miles, let's say, that's a big area. And I could bet you for sure even in Wyoming, there's 100 people using Starlink in a 100-mile radius. Maybe if it gets, more popular, it could even be 1,000. So that is additive then?
It is, because microwatts per meter doesn't specify a frequency. That is just the culmination of all power in that whole spectral area summed up. So yeah, it doesn't, even if it's at a different frequency or polarization, it's all additive.
So would that be then spread out over the 100 miles, or would that be like in any given point
for every meter squared?
Yeah. Okay.
So
That's already taking the area into account. Okay.
Right. So
I'm stupid, but
well, you could also convert it to volume if you wanted, but power density is specified in area. But point being is your Starlink receiver receives from space. You don't need to worry about the transmitting from Earth to space, because that's just blasting a beam straight out into space. I mean, it's relatively safe, I guess, unless you're in an aircraft flying by, no one's going to get hit. But the bigger deal is that your Starlink receiver then immediately converts that received Ku-band signal into a Wi-Fi signal. And so now you're sitting here, and your main concern then is the Wi-Fi again. So it's kind of the same issue.
Yeah. We talked about this yesterday. I think it's an inconvenient fact, but to me, I'm still concerned that it's just against people's will. It's say maybe we did figure out some way to get hardwired fiber, point to point internet in a homestead, off the grid area. But then there's 100 people who have Starlink within 100 miles of us. That's unfortunate repercussion of just what we have to deal with. And now I know that's just Starlink, right? You mentioned, these other satellite mesh networks are going to be formed. This is just maybe one of a handful. So then that's a multiplier effect. And I know Elon wants to just keep it going. So
and it's, satellites aren't new. These are just low Earth orbit satellites. So we've had geosynchronous satellites that shoot down satellite TV since I was a kid, since I remember. So those satellites have been here the whole time, and those are indiscriminately just blasting the whole side of the Earth with that signal.
Are you looking to get the benefits of grounding and earthing, but really just can't be barefoot all the time? Yes, you know what I'm talking about, right? Absorbing free electrons from the Earth, improving your circadian rhythm and blood flow and vitality and redox. And that is why I'm excited that this show is brought to you by Rhizal Shoes. Rhizal Shoes are, in my awareness, the only non-sandal grounded shoes. They have slip-ons and they have cool boots as well with laces that are not only grounded via a copper plug, but have leather outsoles made with water buffalo hide. So they're all natural. They are grounded and they're barefoot and minimalist with a wide toe box. This is imperative for foot health, and it's really going to keep you connected in a modern lifestyle setting, so you don't have to walk around barefoot all the time. I love them in the winter time. I can wear socks with my slip-ons and not be freezing cold trying to be grounding. You need to check them out, folks. Rhizal Shoes, RHIZAL.co. Rhizal.co is their website. Use code DRadio at checkout for 10% off and get your shoes, get grounded, get connected, and improve your health.
What frequency are those using?
I don't know what they're at.
I forgot.
But the distance is much greater. So you have.
So that's dissipating.
It is. Yeah. But here's the kicker: is I don't know how much of that's in a vacuum, right? When you're that far away from Earth, some of it's in a vacuum. When electromagnetic wave travels in a vacuum, it travels unimpeded. It's only impeded when there's atoms and molecules in the volume. It's kind of the opposite of sound. Sound travels unimpeded through a super dense structure. But you don't get sound propagation when there's nothing in the air, right? If there's no sound in a vacuum. So sound and electromagnetic waves are opposite like that.
That's fascinating. It's just an unfortunate reality. I think Starlink maybe not as bad as people think from the total exposure perspective. Again, your Wi-Fi at home, like Rob mentioned. And again, Wi-Fi is typically at 2.4 gigahertz, but it's moving to 5 gigahertz, which you could argue maybe, again, you're getting the higher frequency, you're getting more disruption from physical barriers. So you could argue it might even be a better thing, but that's where the hard wiring. So could you hardwire from a Starlink connection? Is that?
I don't know. I didn't consider that until you brought it up, but I would really hope you can ditch the Wi-Fi component and just have an Ethernet output. That'd be a shame if they didn't.
I'd imagine you could, right? I mean, it's probably still a router, and then you could probably just plug it in.
So maybe there's a way to via software disable that Wi-Fi connection, and then you can just do regular, switches and Ethernet.
So that might be the best solution for folks looking to like escape the city, build their own house. Is potentially Starlink with hardwired, or what are we saying, the point-to-point system. That's
you can also get point-to-point internet systems where you use a very narrow beam with dish that they communicate point-to-point. I don't think you can't get them everywhere like Starlink. That's the advantage of Starlink. You don't have to have all this existing ground infrastructure. You just pop up a piece of infrastructure and you get it from the sky.
Yeah, it's fascinating. And the last part about maybe the higher frequency waves that we were talking about is kind of getting into the vehicle space, the cars, or just like other stuff that's coming with millimeter waves. And I was telling you how I know my 4Runner has a millimeter wave sensor that's 77 gigahertz, but I stopped using the cruise control because I was just like, I don't know what's going on here. I figured it was kind of shooting out mostly in front of me, but you kind of brought up a good point saying that you don't need to worry about your car. You should really be worrying about the other cars.
Right, because, imagine yourself in the driver's seat or passenger, a person in the vehicle. That front-facing radar is designed so that it's not pushing energy out the back end towards the driver. It is designed as an array antenna to push that energy forward to scatter off whatever's in front of you. So now you find yourself in a position where when you are doing that, you're kind of illuminating the person's back of their head in front of you.
Yeah, but because it is millimeter waves, 77 gigahertz, like 100 yards away or 50 yards away might not be very high power density at that point. But
right, and when you start adding up all these smaller density sources, you wind up with a big soup bowl.
Yeah, to me, that's always the concern, right? It's like everyone's like, oh, it's so low power, it doesn't penetrate our biology, which is true for the electric field component, maybe not the magnetic field component. And there are proven effects of millimeter waves. Dr. Martin Powell has a really nice review on that. And but they refuse to study this stuff because they know it's just like, we're just going to keep it coming. And I've read articles saying they want to point a millimeter wave sensor back at the driver to measure your vitals, biometrics, for the safety of others. So that's where it becomes a major concern to me, is like they're kind of like, they're wiggling their way into the room, they're inching forward, saying it's so low power, it doesn't matter. But then all of a sudden, you have 100 to 1,000 sources of low power. Well, they're not very low power anymore. And then they want to beam them directly at your heart. I'm concerned.
Yeah, there's so many sources, even past cars. Have you heard of in-flight wireless internet? How the heck do you think they get internet in an airplane?
They blast the plane?
Yeah, one company, one of the biggest companies in the United States, GoGo, has about, I think, 200 ground stations that are scattered across the United States. These are high-power transmitters that blast from the Earth up. So most of that energy density is going up away from the Earth. But antennas have side lobes, and when they're steering close to the ground, they can reflect off things. It's just a summation of all these little sources.
Yeah, and the plane is really bad because then, you're completely in a metal tube as well. And You're just getting, it's at the back of your head now, the TVs and the Wi-Fi receivers. So people wonder why they get so dehydrated on long-haul flights. And that's like mitochondrial dysfunction 101. And it's only getting worse. Like, I don't even want to go on a plane anymore, but it's just like you can't even avoid these things. So, how do we, in 6G, we could talk about is just pushing it higher and higher, which is kind of a trade-off again, because they're just going to run into more and more atmospheric losses, right?
Yeah, the problem, the engineering difficulty just goes up and up, because as you go into higher and higher frequencies, all your components become smaller and smaller and smaller. Like, things are getting very small. You're talking about little, microscopic integrated circuits. Your little traces matter. Any impurities in materials add up. All these engineering challenges become escalated. But I want to point it out. I had a thought. Now, you don't need just a dedicated antenna to have an EMF exposure. So there's sources, like Christian is pointing out, this TV in an airplane that is behind your head. It doesn't have an antenna on it, probably, but it has other electronics that switch back and forth and create electromagnetic propagation. So electromagnetic waves can be sourced from more than just like an antenna or Wi-Fi or Bluetooth. They come from the actual power supply switching of these devices.
Yeah. And that's, to me, working in semiconductors, I realized that. I mean, just the amount, everything, you take one PCB, the amount of switching transistors, the amount of LEDs, the amount of like just pulse width modulation on like a single circuit board is astronomical. And that's in literally everything we use. And that's not even that's like a lot of that's in the kilohertz range, which people don't even measure that very often with a meter. So we're basically being exposed to the entire EMR spectrum now with non-native sources.
But Bitcoin miners are good to sleep next to in your bed, right?
Yeah, man, we need it. We'll attack that. But maybe we finish off. It's like, how do we build a future? And this is in line with Bitcoin, right? Like, how do we build, like, what's the ideal future look like to where we can use internet, we can use technology, but it's in a more, symbiotic way with our biology, how it's meant to function. And we've thrown back some ideas. So this is like totally open-ended. I'm curious, you have a blank piece of paper, you have 100 acres building your own house. Like, what are you doing? And then how do we do this for more than just like one family?
Right. So, an individual or a family can move out. If they start from a blank sheet, you start with the way your electrical system's laid out in your house. You cleverly design your breakers so that there's a dedicated circuit breaker to your bedroom. There's one to your kids' rooms. There's dedicated breakers everywhere that if you want to, they can be switched off at night, which is probably a good principle going forward. And that, that also ties hand in hand with EMF, like blue light. That's just a higher frequency of EMF. It's all EMF in the end. And then you get into like shielding those conductors in your wall. You want to put them through conduit and ground those pipes. That's probably the safest way to do this. And then you're kind of left with like your water system. And I think I would choose PEX, learning what I learned in my house, but I'm not sure I'd necessarily drink the PEX water. I'd probably have some other filtration system, but I'd have to do more research to see if those kind of plastic contaminations get removed from like reverse osmosis. I don't know if they do. Yeah, and I would definitely design my whole house without Wi-Fi. I would have Ethernet jacks everywhere. I'd have it all grounded. I would run Ethernet out to any auxiliary building where I needed. I'd still have a cell phone. We don't need to go back to like cavemen to do this. There's always a balance. But I don't know how the general population is going to move forward with this. I mean, the real answer is, it's a tough answer. And the answer is probably we need to go to a wired future. Now that's going to not really work for the general population. So honestly, what I see happening is it just getting way, way worse and people getting sicker and sicker and sicker.
But we'll adapt, right? Like biology will just figure it out.
We'll figure it all out.
It's non-thermal. It's not ionizing. It's just giving us a nice, cozy, home to live in, right? It's scary, man. And it's like, yeah, we don't know. I mean, I think we need to engineer better, technology for the first part is, there are simple things. Everything that Rob just said, hardwiring, putting distance between you and your technology. These things don't cost a lot of money, and they work. And if we do that, if you shield the electrical in your house or, get crazy and maybe make a DC off-grid home, at least to the endpoints of, half of your units, you can remove like, I don't know, 80 to 95% of exposure right there.
Right.
And
DC lighting is a really interesting idea.
Yeah.
I would really consider it based upon what I know about lighting now.
Yeah, DC lighting and then DC control, so we're not getting pulse,
Right.
flicker to just destroy our retinas.
And then while I was kind of pessimistic on the future of Wi-Fi, I think screens are a different deal. I think there is definitely some hope in screens that aren't like blasting non-native spectrum in your face all day.
Yeah, and that's why, I started, working with the daylight computer. I'm stoked. It's like we can engineer these solutions. I mean, Rob and I sitting here the past day have just thought of like 10 great ideas, but, nobody's going to give us money to do these things unless they prioritize, health. And eventually it's going to get so bad. We're already starting to see this transition, but eventually it's going to get so bad, and it's obvious, right? I mean, the studies are out there. You should be warranting caution, but it just goes against the major thing. Probably the big. I mean, we have a tech economy, right? So it's the biggest stool, or the biggest leg of the stool in our fiat economy. So it's like if we take that out, the dollar is broken, which gets into Bitcoin. The Bitcoin mining, how this is kind of a conundrum, right? Because Bitcoin is a very, native to the internet. I mean, miners are EMF, monsters. How do you think about this from like having Bitcoin, being a Bitcoin maximalist, but also wanting to have a connected to nature lifestyle? And it's a challenge. And I think about it often.
Yeah, it's an interesting dichotomy, I guess. In terms of Bitcoin mining, I don't think miners should be anywhere near humans when they're running. They need to be in isolated environments. I mean, you kind of be a fool to be sleeping around a bunch of Bitcoin miners. They're just like we said, EMF monsters. They're producing all sorts of spectrum. Living in harmony with Bitcoin like that is a tough one because but like I said earlier, we're not proposing going back to caveman stuff. I'm proposing really removing a lot of these wireless connections. But what we're faced with is just like people are addicted to sugar and they can't give it up, or addicted to porn or whatever it is, they're addicted to Wi-Fi. They're addicted to instant connectivity right at their fingertips. And maybe we need to let a little bit of that go and like have a little hassle getting on the internet through a wire. That leads to a lot of other perks.
Yeah, I mean, we're so enthralled. It's not even funny. You could shield the miners as well, right? Like pretty well, I'd imagine.
Yeah, just need to get that airflow in and out.
Yeah,
Shielding would work really good for a miner. Faraday cage would be a good idea for a miner.
Yeah, it's not inconceivable, right? Like there's solutions. We're all very smart. It's just nobody's thinking about it because, like we said in the beginning here, all the engineers they don't consider the biological effects.
No, none of them.
And none of the people that are worried about the health effects have any background in engineering. So they're just telling everyone to buy pendants and harmonizers. And maybe we talk about that really quick, Rob. Can we buy a harmonizer to block all the EMF from everyday living? It should be that easy, right?
Artificial blue light from technology is destroying our health. It disrupts melatonin production, sleep quality, and our circadian rhythms, which has been linked to pretty much all chronic disease. It also rewires our dopamine reward system, which makes it addictive by design. That is why I'm so thankful to have found the Daylight computer, the first company in the world making a computer that has a blue light free screen. They use paper reflective screen technology, so it's blue light free, flicker free, eye strain free, and is easily used outdoors, so you can use technology while getting the benefits of full spectrum sunlight. For more information, you can listen to our recent podcast with the founder of Daylight Computer, Anjan, on his incredibly inspiring story on why he wants to bring technology to the masses that is not detrimental to our health. You can go to buy.daylightcomputer.com/dradio to pre-order the Daylight tablet today and begin using your technology in a fashion that's way more in line with our biology and nature.
Absolutely not. Like any little tiny device that you can put on your body or wear that claims it blocks EMFs or creates some like halo around you. And then my favorite is when they also advertise that it doesn't impede your cell signal. Wi-Fi and Bluetooth and cellular service work fine in it. No, I don't have any scientific experimental data to stand on for these specific devices, but I have a career of electromagnetic engineering, and I would tell you that if there was a device that could do that, it would be heavily implemented in the military, and I would have known about it. There's no device that can do that.
Military is all about, the future of warfare, as you mentioned to me, is all electromagnetic, right? Like jamming signals, getting kind of the upper hand on the spectrum.
Right. Whoever controls the electromagnetic spectrum essentially dominates the war front, and that's going to get more true into the future.
That's what's scary to me, because that's what's driving like 6G and everything forward. And I've read those 50-page documents on the future of warfare. We've already seen the active denial systems, which is 95 gigahertz beam being used on crowds in Australia for COVID. They can physically move you. They can make you feel like your skin's on fire. But guys, this is non-ionizing radiation, so it's
completely harmless.
It's perfectly safe. It's scary because then it's like, yeah, it's for military use, but then all of a sudden the military turns on civilians because, you know, they're revolting and trying to buy Bitcoin. You know, that's a scary future potentially.
It is. And back to the harmless thing, it's hard to prove it has an effect because, you know, you can sit here throughout one day and you can use a ton of Wi-Fi and be around all these signals for short term and nothing happened to you that day, right? But it's like smoking a cigarette or something. I mean, maybe that's a bad analogy, but you can smoke a cigarette once and there'll be no health effects of it. You might have a sore throat or something, but if you continue your whole life, that's where this long-term exposure is the concern.
Yeah, the duration is tremendously important, and the research shows that as well. And that's why the sleep sanctuary, I think, is imperative, because if you can take a break, it's unavoidable. Yeah, well, it's unavoidable, right? Like, it's even in your room, like in your kitchen, you're like, wow, you know, I would love to get it 10x lower. And you've
a lot of things.
You've done almost everything. I'm the same way. My breaker to my bedroom is off. But yeah, the sleep sanctuary to me is the biggest thing, because that's when we're repairing and restoring the day's damage. We're going through autophagy, apoptosis, and we know that EMFs can alter that, alter mitochondrial function. And if we don't have that, Wi-Fi disrupts melatonin, blue light, of course, as well, which is another EMF. So that's, to me, the number one thing is if you can prioritize your bedroom and your sleep sanctuary, like, you're at least giving yourself a fighting chance. Right. Whereas, yeah, you're going to be degraded. And a lot of the studies show that once you hit like chronic exposure levels, which can be like above 24 and 48 hours, that's when the biological effects really start to take place, at low power densities, because, yeah, it's just like this persistent exposure. And some people probably go like, 10 years without a break in exposure. I mean, that's why I love going to the mountains and having nothing, and I can take out my reader and like, there's nothing there and I don't want Elon Musk. I don't care if it's, whatever 0.1 microwatts per meter squared. Like, I don't want anything.
Like a prison.
Where it's inescapable. But that's why the goal is not perfection. Perfection's impossible, people. Right. Rob and I have tried, but it's not possible. And maybe we're going to try a little harder.
A nice balance.
But yeah, so how do we get more Bitcoiners? Because Bitcoiners are going to be the one who fund this in the future. This is how I think about it. Bitcoiners, we're going to have the money. We're going to want to fund the research that actually matters. And that's going to be about using technology wiser, electromagnetic fields, water, sunlight, things that nobody's funding in the centralized world. How do we kind of bring them over? And have you, thought about that at all? Because it's one of my biggest challenges. Yeah, it's easy to overwhelm people. They might be on board with the food. A lot of the Bitcoiners, a lot of people are like, all right, I cut out the seed oils. I'm eating red meat. I'm getting outside more. There's like almost a progression. And then it's like, oh, EMFs, like, oh, you're telling me to unplug my Wi-Fi and stop using AirPods are giving me brain cancer. I'm like, and then you lose them.
You lose them. Yeah. I mean, I guess for what I've experienced through Bitcoin is to really understand Bitcoin right, which in my opinion, there's very few people who do. You need to have a multidisciplinary approach to it. You need to come from many different angles to understand every aspect of it. A lot of our knowledge is siloed, like you were talking about earlier, between like the engineers don't understand the biology and the biologists don't understand the engineering. And I understand that because I don't really understand the biology fully. I know a lot more now, but when I was an engineer, I didn't really consider the biology. And if you talk to anyone, they just dismiss you. So I think for me, it would be having the research and the data easily digestible. There needs to be, and incredible. There needs to be some way to understand that it's credible and it has been a repeatable data set with enough statistical numbers. Because that's what I saw. I saw some of the data and I started believing it. So yeah, I don't know. You need to somehow educate the Bitcoiners about this biological effect because they're primed for it. Bitcoin opens you up to start thinking about all these things.
Yeah, I mean, you should have the mindset of question everything, like everything. And don't believe me. It's just, hey, consider this perspective. Like, consider that maybe big tech doesn't have your best interest in mind, that technology is made to be addictive and they could engineer better solutions, but why bother?
Well, and here's the deal. You can get on Google and go research what we're talking about, and you'll learn that we're full of shit, right? Google will tell you
on
that.
Google, yeah.
You'll learn that that we don't know what we're talking about and that it's not even a concern. But the funny thing is, if the same person goes and researches about the money system, they'll learn that Bitcoin is like dead and stupid, but they don't believe that. They know Bitcoin is it. So I don't really know how to jump that gap.
Yeah, I think it's just slow progression. Again, you can't, like you said in the beginning, what did you have a very hard time doing? Convincing people to buy Bitcoin. You almost have to come to it like on your own. And then when you're ready for the orange pilling, when you're ready for the EMF pill, you will be ready. But there's like steps that need to happen. And I think COVID accelerated a lot of things. Bitcoin's accelerating a lot of things. But the EMF one, it's tough. And same with the light, which is EMF. It is the main input signal to our biology. Our biology is electromagnetic. Like, this is undebatable at this point. And it's cool as two engineers to have discovered this. And now it makes sense, right? Like, that's what we're hardwired to do. And so I think any Bitcoiners listening, most people in this podcast are probably health listeners that are trying to get more into Bitcoin, but still, any Bitcoiners listening, just consider the perspective. And, that's one of my main missions as well. So
something I've realized since COVID was, you talk to people and they don't have that much confidence in their medical doctor. They go to the doctor and the doctor gives them advice and they're like, I don't know if I really trust it. I've heard that so much. And maybe that's what it's going to take. Maybe it's going to take people doing like basic health research on their own to wake up from this and seeing that the big system doesn't really care about your health, right? It's there for profit.
Yeah, and I think a lot of folks are already doing that. It's just like
right.
EMFs is like, again, it's like an advanced. It's like
it's like the tip of the pyramid.
It's like the last like little crown of the tinfoil hat you get.
It's like expert mode, pretty much.
We're advanced, conspiracy theorists here.
Yeah.
But you also have just a crazy depth of knowledge about Bitcoin as well. Being an OG, being an engineer, diving deep into the technical aspects. What are your biggest concerns about the network? What are things you would like to see really like advance? Like, are you bullish on Lightning Network? Like, how do you assess the state of affairs currently and like where we need to get to in maybe the next 5-10 years? Because ETF's approved, things are accelerating. And, we could talk about if that's good or bad, but I'm curious, as an engineer, as someone who's very technical, the network itself, fees are high. What are your concerns? What do you think needs to happen really for this to keep proliferating in the coming decade?
Yeah. And there's a lot of different thoughts around there and a lot of different camps and arguments. I guess one of the biggest issues I see, and it's probably the most obvious one, is the on-ramp, off-ramp privacy of Bitcoin. So Bitcoin itself is pseudonymous. You're transacting with these alphanumeric numbers, and if you don't have any other data, it's anonymous, right? Unless you are linked to that address. And so when you buy Bitcoin from Coinbase, you're linked right there. Then you can be tracked with everything you do. And if you're perfectly private and you go sell your Bitcoin and off-ramp, then you're linked throughout your past. So yeah, privacy is a concern because of the leadership of the world. If the leadership of the world wasn't so authoritarian and want control freaks and all these things, we wouldn't have to worry about it so much. So yeah, I think that's something that has to be solved. And, Lightning was supposed to come around and do that. And I just don't think Lightning adoption has been as much. Maybe we're just too early in that. I feel like it's too early all the time in Bitcoin. It's really amazing me how slow the progression of people adopting Bitcoin is. And also people think that they're so addicted to their new iPhone coming out or the new car. Like, I want the iPhone 13, then the 14, and the 15. I don't want a money system like that. I don't want a money system that is continuously being upgraded. I want something that was finished. The way I look at Bitcoin, it was pretty much a finished product when it launched. It needed some work. There's obviously some things that need to be fixed and upgraded, but I look at Bitcoin as a finished product. It is what it is. I don't want it to be upgraded because that doesn't make it sound over time. If you can just keep upgrading it and doing things, then what's the point? You don't know what the future holds. But I do think I'm not technical enough to give accurate recommendations on like an on-chain block size increase, like how many more megabytes until you cross that chasm to more centralization, or that there's like layer 3 privacy methods, and a lot of people have already given up on Bitcoin and have moved to like Monero and other things like that. And I'm a Bitcoiner, and I think it's going to work out in the end. In terms of privacy, it is an issue. But when I transact Bitcoin and buy it or sell it, I like to do it with individuals. I don't go to centralized exchanges unless I have to. But yeah, I think that is the solution, is to just be peer-to-peer with actually real people the way it was intended. The problem is people go on Coinbase and they buy a Bitcoin. No, you don't. You don't buy a Bitcoin. You buy a digit on their database. The only time you actually interact with Bitcoin on Coinbase is when you withdraw it. Then you just interacted with the network. So up until then, all these Bitcoin users on Coinbase, they're not Bitcoiners. They're just buying a digit. And we know from the legacy banking system that they're just going to inflate those numbers. And who knows if they have the same reserves as what they sold.
Yeah, very valid, I think, across the board. I kind of came to the conclusion as well recently that it's like there's only going to be a small percentage of people who actually use the Bitcoin network peer-to-peer, who actually self-custody and actually do all the things that is quote-unquote intended for. And everyone else is going to be, they're going to be on paper Bitcoiners, but not Bitcoiners,
Right.
Whether that's through the ETF or they're just holding on exchange or wherever. And that's just the reality of it. I think 95% of people just aren't willing to put in the proof of work for their money, for their health, for anything. And that's all right.
Exactly.
But my only concern is that becomes a regulation, legislation issue, and then they attack us for, self-custodying and what have you. But, we can be optimistic and just do things the best we can. And that's, owning Bitcoin in any form is probably better than nothing, because at least you're hedging against the deflating dollar or
Right.
the inflating, devaluing dollar. But yeah, people are just lazy, man. And
I think COVID really blasted that in my face, like how lazy and how people just listen to authority. That's the difference in me. I never listened to authority. I educated myself about my own solutions. I never listened to authority. I never liked being told what to do. And I think that is the fundamental pillar of how I got so into Bitcoin and how I'm into health and all these things. When I hear official sources telling me something, that makes me question it more, because we know how just how full of shit they are. They're liars. They lie and manipulate you to get what they want out of you. So the reason I'm not an engineer anymore, well, I can call me an engineer or not, but I'm not employed right now, is because I didn't want to get the COVID vaccine. I was working at home 100% in my office here, but Biden's emergency mandate required that even military defense contractors who he put in there work at home have to be fully vaccinated. And I'm like, I'm not doing it. I, at that point, understood that the vaccine didn't stop transmissibility. So I looked at the situation. I said, why would I be a threat to anyone else if I am just as transmissible as anyone else? And I did a bunch of logical, simple thoughts. And it's very simple for me to say no to it. I don't need it. Gone. And I stood up to my guns there and I got terminated.
a lot of people have a similar story, and I definitely don't like being told what to do either. Thank you to my lovely mother for giving me that trait. But it's crazy. Yeah. I mean, people just roll over once it becomes inconvenient. But the way I found is a lot of people also just got shoved into a corner as well. And they kind of just, financially, I
Right.
mean, they didn't have it.
So-
The only maybe a good reason you're able to do that was because of Bitcoin, right?
Probably, yeah.
And it's, for me, it definitely is the same thing. If I didn't have Bitcoin, I wouldn't be able to confidently leave the engineering world and, a
Right.
decent salary. So we need opt-outs. We need alternatives. We have one in money. We have Bitcoin. And again, the people listening to this show, they're amazing. They're probably going to be part of that 5% who are going to do their due diligence, going to want to self-custody and do all the right things. We have, now an increased opt-out from, the food health perspective, and we're going to get right into AUPA Bar now. But we need more from technology, and we need just kind of alternatives everywhere. We need to create an entirely different system that's outside of centralized control.
For sure. And just kind of circling back, I had other coworkers that didn't want to get vaccinated. They had the same kind of few of them. I'll just say a couple of them out of the 150 people. Most people immediately bent over and just did it. But the couple that who stood up with me, they had, money they had to bring home to support their whole family. And they dangled their salary above their head, and they couldn't do it. They couldn't put their family at risk. So the smartest solution for them was getting it. And that's what they did. But there's other people. I know some people who were like, yeah, I got vaccinated so I could go on a trip to Costa Rica. I'm like, dude, that is the weakest thing ever. That's how they get you. And a lot of people did it. They did it to take the easy way.
A lot of people want the easy route, Rob. That's programmed. It is programmed into our biology, right? I mean, it's kind of hard to overcome it, but we are dumb monkeys at the start of it. And, that's why we'll fall for sugar and blue light screens, because our biology is innately addicted. But we're in this, overconsumption every day. And yeah, it's wild. So getting to the health rabbit hole, how did you, what made you want to start a company that kind of offered a solution, offered a better alternative? Because the AUPA Bar to me is incredible. Like, I'm active, I'm in the outdoors all the time. All the bars on the shelf and like Whole Foods, natural grocers, like most of them are shit. The jerky is really expensive, not high calorie enough, and questionable quality a lot of the time. So I love the AUPA Bar. I use it all the time. And how did that journey start?
Right. So I guess the blessing in disguise is I lost my engineering job in about 2022. And I have 2 young kids, so I hung around for about a year here. I'm still here, but I just primarily focus on hanging out with my kids and raising them. But I wanted to be someone who they can look up to. I don't want to just be a lazy bum all the time. I mean, I work my ass off on this property, but we wanted something to put our work into. At the same time, we were going on road trips, and after this whole COVID vaccine thing, we became very health focused. Like, we started falling down this food rabbit hole. And it didn't just happen then. Before that, we just realized there's just shitload in everything. There's so many products that are just fiat sludge, just industrial sludge. And there's this very specific time we were on a road trip, and we literally went gas station to store to gas station. And I came out empty handed every time because I went in to find this ideal snack, and you can't find it. The only thing I ever found was a bag of cashews, and they didn't have seed oils on it. I was shocked. But almost every other nut or anything you find something, you look at it and there's soybean oil on it, or canola oil, or a number of whatever other oil there is. We just got sick of it. And then we were home one day after this trip and kind of defeated from that. And we were reading a book about Native Americans and stuff. And my wife brought up pemmican. I was like, what the hell's pemmican? And I started looking into it, and I was like, this is amazing. This is amazing stuff that we have lost in our culture. And we just made it for ourselves. We didn't really think about business. We were just making it for ourselves. And what we realized is that when we made traditional pemmican, like, our kids didn't like it. It was harder to eat. It doesn't excite your flavor palette like other foods do. And so
it's kind of like a survival food.
It's a survival food. And that's what the early explorers did. They lived off it, but they didn't have other options. So we kind of went out and were like, let's make pemmican great again. And so we took that recipe and, we added some dehydrated fruit and some butter and some honey to it. And our intention was to only add an ingredient that can be sourced from a typical farm, right? A typical farm can source all those ingredients. And that was our ingredient list. And we made them for a little while, and we had a couple people tell us that we should sell these because they've never seen anything like it. And I thought about it for a while, and I was like, man, Bitcoiners would love this kind of bar. We could start marketing to Bitcoiners, and I think we'd be doing them a service, and it'd be a great product. And that's what we did. We went all in on it. We built our kitchen right here behind us. This is the AUPA Bar kitchen. The start of it, we plan to get bigger. And we source from what we call some of the best beef in Colorado. We don't get feedlot beef. It's all regenerative, grass-fed beef. So one of our ranchers even takes Bitcoin as payment. We incentivize Bitcoin sales. We give discounts. We want to have Bitcoin. We want to become a Bitcoin node, an economic node where Bitcoin's coming into us. We send out what we call perfect food, and then we go take that Bitcoin and buy more beef and do this whole cycle. And it's been rather challenging to not add any food additives into it, because as we get involved with the USDA more, they want to add potassium sorbate. I can't remember the other additive, and we just said, no, we're not doing it. Like, why? If we have a product that works now, why do we need it?
Is that something that would be on the ingredient label, or could you like skirt around that? Because that's what you were telling me all this stuff, and I was like, I feel like there's stuff in our food that we don't even really know just because of the USDA.
Right. We'd have to put that under label because it's added into the bar. But for example, what I was telling you is that when they make pre-made hamburger patties, if your ingredients even say the best grass-fed, grass-finished, regenerative beef on it, well, when they're going through the assembly line at the USDA, they can be sprayed with unknown microbials or antimicrobial agents or antifungal agents, and they don't have to put that on the label because it's not part of the food. Somehow they've messed with the verbiage so that it doesn't have to be on the ingredient list, but they're still sprayed with a bunch of stuff. And they need to, because otherwise salmonella and E. coli will break out in these big processing facilities and get people sick. So they kind of have to do it.
Yeah, because they're that like unsanitary and moving that much volume, and it's crazy. What else have been like big challenges that maybe were unforeseen, something, you know, potentially that even you knew you were getting into, but you'd like to overcome? Because I realize that, the USDA, starting anything in food is like extremely, extremely challenging.
Definitely challenging. So in terms of the USDA, our biggest thing with them is they're just slow. It's been taking forever to get stuff going. I feel like since COVID, they're even slower. There's like half the people are gone. You call in and no one really answers. We are supposed to be awarded or denied a grant last November 2023. We haven't even heard an update, and it's already 2 or 3 months later. But the challenging part in terms of the AUPA bar itself was taking different. So we're so used to having our food homogenized. Like you go to the store and you buy whatever it is, some orange juice, and you expect it to be the exact same next time, or whatever product, it has to be the exact same every time. But that's not the way natural foods work. So when we're sourcing different beef, we get beef from small ranchers. And so sometimes we get all of our beef from like one animal. It's like a full animal. It's maybe has a little different fat content than another animal. It could be a different breed. And so you get this varying beef inputs. Even though they're the same cuts, they're different fat contents. And so we had to really figure out a method in our bars to come out with a good consistency every time. And while we do hit a pretty good consistency, I believe every batch we make probably has just a slightly different taste. And we like it that way because that's the way natural foods are supposed to be. We don't need these same exact homogeneous foods every single time.
Yeah, it's just like not real. I mean, it's not it's not realistic in any sense of the word. You know, what has the feedback been like from people, and how do we get more people on board? Because for me, I was like, I found you guys. I'm like, this is like a match made in heaven, right? Like this is what I've wanted for a while. Like I don't have to eat stupid Lara bars or bring like a pocket steak, or, you know, I still do that maybe, but it's kind of not as convenient for sure. And you know, people I've turned on to it love it as well, but it's some people are like, you know, that aren't, I guess, maybe as meat centric as we are, they're not really into it, or it's kind of like, oh, that's weird. Like, is that jerky, or what's going on here? So,
right. So
how do we overcome that?
People like you who love it, and then we ran into people who really dislike it. And a trend I've seen is people who are into health and have experienced eating like natural foods, pretty much they like it. And we've gotten different feedback about the texture. It's really hard designing a product because if you get half the people who don't like the texture and half the people that do, what do you do? Well, so that's about where we're at. And we left it the way it is because we enjoy it ourselves. Some people don't like it, and that's fine. We don't expect everyone to like it. But a lot of people who don't like it are people who are used to eating Cliff Bars and they expect it to taste like a Snicker bar or something. We had a guy that told us he expected it to taste like a chocolate bar. And we're like, dude, the ingredients.
There's no chocolate in here, sir.
Chocolate. It's beef, butter, honey, and tallow. And if you want to get the berry and nut one, you can get that one too. But yeah, I guess generally speaking, people's taste buds and palates are so out of whack compared to what real foods are. We're so used to buying these factory produced, ultra flavorful things. And don't get me wrong, the people who design these chemicals and food additives and all these things, they're brilliant people who have PhDs and they work at these food companies and they know exactly your psychology, and they design food to excite your brain in this unnatural way. And so some people stepping back into an AUPA bar are like, oh man, this is too like real or something. But
It's too boring for
it's too boring.
For the low dopamine brain.
Right. But if you don't know, our bars are very simple. We source the purest, high quality ingredients. It's grass fed beef, regenerative, tallow, butter, and honey. We have 2 variants of that: blueberry almond and cranberry pecan.
Yeah, and even the grass fed, like, I've posted about this, I've talked about this. Like, people eat a grass finished steak and be like, this doesn't really taste good, or like, this is off. I'm like, no, this is what it's fucking supposed to taste like, people. Like, this is real food. You just been like eating JBS and Cargill beef for your whole life. That's like disgustingly like full of corn and soy fat and like you're eating a diseased animal. And now you move to something that's literally like a high octane animal that has less fat content but better fat content, and a whole diverse pasture diet. And the nutrient density is proven. We've talked to Stefan Van Fleet. Like, the research is now out there. Like, the quality of life, the feed, the pastures that your food is eating will be translated to more nutrition for yourself. So, like, it's undebatable.
Right. And a big part of us was the quality of life of animals. I mean, we've all seen pictures of feedlots and stuff. And, I don't want to support any of that. Our company doesn't want to be part of that. We want to support small farmers and ranchers, because that's how we rebuild this food system. Is we do it locally, we do it small, and we do it the right way, the way nature intended.
How do you think, say AUPA Bar blows up, like, is it even possible to have like a big, large scale company like that's doing it still the right way, you think? Or is there a certain scale where everything kind of just goes to shit? Because I think about this a lot, and you see every single good company, like Primal Foods and whatever, all the toothpaste brands, deodorant brands they always get bought up by Procter & Gamble, General Mills bought Epic. Like, they always get bought up, and then eventually it's like they ride out a wave for a couple of years, and then they're like, all right, we're going to see if anybody notices. And it's like, to me, the most fiat thing in the world. So how do we, how does Bitcoin like enable that from not happening? And is there a point of no return for scale of quality?
I think there is. We've talked about this several times, my wife and I. If we ever got the company big enough, we've decided we don't want to have it big. We want to have it a size that's manageable for us and maybe a small amount of employees. We're not after some huge multi-million, or maybe multi-million, that's still small, but hundreds of millions of dollars or $1 billion business. We don't want it. If it gets to that point and we have to match the demand, well, then we have to look into some other way of franchising out the business and creating small local ones. That's what we want to do. We don't want to work up this company like another meat bar on the market and sell it off. We want to keep it small and local. I say that now, and I hope you can come back in 5 or 10 years and ask me the same thing. And, I didn't sell it off to General Mills or something that I really never want to.
I think that's like the franchise piece is interesting, right? Because that's really actually pretty prevalent in our society. McDonald's, Chick-fil-A, Starbucks, like a lot of these are franchises, but
it doesn't fix the problem.
Yeah, it doesn't fix the problem. But if you could do it a more decentralized way, I think it could work. Say there's like a 25-year-old in like Georgia who wants to do AUPA bars. It's like, yeah, maybe there's an agreement somehow, or without like, stealing the business, and it helps you scale. Like, I feel like there's ways to do it, but I love, because it is the hyper local approach. And especially for meat, it's like, local beef producers, they shouldn't want to ship their beef to like the East Coast. Like, that's stupid. That's a waste of energy. Like, exactly. And that's what, when you have the incentives aligned, like, I feel like that'll almost kind of naturally like work itself out.
Yeah. And right now, since we've only been around for a year, we are doing most of our sales shipping out. And that was not our intent. We thought we would be in local stores sooner. We want to sell most of our AUPA bars locally. And I mean, it turns out if you want to pay the shipping, you can, but it's not the most ideal thing. We would much rather prefer to be fully USDA certified. Let me step back. Right now with the USDA, we can legally only sell direct to consumer. So that means I can sell to Tristan on the internet. I can sell to him face to face. Any one of you could come to our website and buy it for yourself. But if you're a reseller or you have a store and you're coming to us and say, I want to get wholesale pricing and like sell a bunch of your bars for you, I can't do that we've been limited by the USDA. And
why is that?
Health, contamination, I don't really know. There's not a lot of sense the USDA makes, honestly.
That's crazy. So is it like, are you going to get approved eventually? Or
We're in the process of it.
Are
It's
there
just taking
things that you
forever.
haven't done that they're looking for, or it just takes that long?
I don't really know what the holdup is, but it just takes so long to get them out here. We've had them out here for the initial inspection. So the USDA people have been out here and they have watched us make a full batch. And then I gave them all the data. They're very picky how we dehydrate our meat. So traditionally, we wanted to do it like a traditional method at lower temperatures, but we cannot do it. Even direct to consumer, we have to hit our meat to 165 degrees or else it's illegal. So we have to go much higher than the natives made it. And, you probably know more how it destroys more nutrients going that high. But I don't think we're at the point where we're destroying a lot of nutrients. But my point is you have to follow all these rules that don't necessarily make sense in all aspects. And it is taking a long time because this bureaucratic process, the USDA. And honestly, we are waiting on that grant because if we win this grant, that's going to be a pivotal moment in this company, because then we'll have a bunch of money to buy machinery that we can speed this up. Because right now, it's my wife and I all by hand, and it's a lot of work. We're really doing proof of work with AUPA Bar.
I love it, man. Is the grant situation there's stipulations with to get the grant? Because I think I had this misconception that grant is free money, but it's kind of you're agreeing to a lot of things to get money. Is that kind of how it works, or,
Right.
or how is it?
As far as I'm aware, it's essentially free money as long as we're using it in the right way. We can't use any of that money for marketing, buying materials. It's specifically for machinery. And right now, I form each bar in a mold by hand. And that takes a lot of time, and my hands get sore afterwards after several hundred bars. So we get an extruder in there and it can extrude bars, and that will change the game a lot. And a packaging. So we didn't intend to have this packaging we have now going so long, but as a small business, you can't just buy a whole bunch of materials and just throw it out the door. It's hard to make a profit. A lot of people say our bars are expensive, but if you look at our inputs and our profit from a bar, it's not that much. I mean, we're not getting rich here.
Yeah, and we talked about the dollar per calorie is really people are spending, a couple bucks on a 80-calorie jerky stick, and, your bar's 300 calories. It's definitely worth it, in my opinion. And I did all that math. I was this is the best deal that exists. And when you're out in the wilderness, you need calories, and you want a small form factor. And I think it's the perfect, fit. But yeah, the USDA is insane, and people don't really understand how centralized our food system is. It is inconceivable. And I wrote a whole book or half a book on it, and it's still every time I talk to people that are in it with boots on the ground trying to start a business, it's tough. And again, appreciating the small, businesses have to start somewhere. Support them, support Rob, support any small business that we work with, that we partner with, because else we're not going to have alternatives. We're just going to get squashed left and right. And it's just going to be a bunch of Cliff bars that are grown with, glyphosate sprayed oats and all this other bullshit. And that's how kind of the fiat world works. But we need to break free and create these opt-outs.
Right. And if we had our way, we would source all of our beef from Colorado and every piece of our ingredients from Colorado, and preferably have them for sale in stores and not have to ship. But to stay afloat right now, and, if you have the economic incentive to have us ship you bars, and yeah, that's awesome, we'll do it. But the end goal is to not ship. We get a lot of Europeans and Canadians asking us to ship, and I'm it doesn't make sense.
No.
We could do it, but we need an AUPA bar in France or something. And in Canada, we don't necessarily want to use all those resources to ship bars over, because it kind of defeats the point of our business partially, but it doesn't in a way, because our ranchers, this money that is coming in is flowing directly back to local small scale ranchers. And that's what we love about it.
That's the key. It's just getting back to a hyper local approach, right? I mean, it's the same thing we're doing with Wyoming based. Sounds can you ship a beanie to United Kingdom? And clothing's, it's a bit different, but still I would love to see some of them doing 100% wool stuff in Europe or in the UK or in Canada. That's the whole point here, is to have it within your community. And then, like you said, you're giving it back. You're sourcing it from the local community and getting paid from the local community. It's all just staying within. And yeah, I think that's what we really need to get back to.
Right. And then another big pillar of our business is the Bitcoin. We don't rely on any centralized party for our Bitcoin operation. I don't want to get into too many details about it because, there's security aspects, but we essentially run our own servers and nodes. And when you buy AUPA bars from us using Bitcoin, we do take Monero as well because we have a big base of customers that use Monero for privacy. And I totally understand that. And, we have a lot of other altcoins asking us to take them. I'm like, no, it's Bitcoin, Monero, and then dollars. That's what we're doing. That's what we are. So I am a Bitcoin maximalist, but I also do understand why you would use Monero. I think it has a place. Forgot what my first point was.
Just running the server, the BTC Pay server.
Yeah,
I mean, that's proof of work. It's not easy, folks. This is not low barrier to entry, like accepting Bitcoin for payment. Like I'm not trying to do this personally.
Right.
This is a setup.
One side of the hand, it is easy. You just kind of have to spin up like a BTC Pay server instance. But for production environment, like having it function all the time, you have to maintain it. And then you add Lightning on top of that. And Lightning is much more time intensive, balancing channels and making sure you have enough received liquidity. And we get most of our payments in Bitcoin. And I'm happy to say that in 2023, about 45% of all of our orders were done either in Bitcoin or Monero. And primarily, I think about 8% of that group was Monero. And then the rest of that, the 92% was Bitcoin. And it was over half Lightning. So I think our number one payment method was still fiat, but close second was Bitcoin Lightning, then Bitcoin on chain, and then Monero. I was very happy about that.
That might be the highest percentage I've ever heard. I know a lot of friends that take Bitcoin payment, but when you incentivize it too, and you're like, fiat's going to be a premium.
Well, we
want Bitcoin.
We had a big decision at the beginning. We're like, should we charge fiat customers 10% more? Because that's more of a negative entry to that. We decided instead of taking that negative approach, we were going to incentivize Bitcoiners by giving them 10% off. Recently, we've bumped it down to 5% because we also give 5% back with Oshi. Yeah. So it is still 10% back total, but you get 5% directly off the good, and then you get 5% sats back.
Yeah, I know like people like Parker Lewis like the fiat premium, but I don't think they really have marketed small products like this that need volume.
And it just brushes off negatively on. And honestly, we have to take credit cards. Like some businesses are Bitcoin only, and we've been kind of asked to do Bitcoin only, and I'm like, well, we can't survive. There's still
we're years away from that, but it's good. I mean, 45%, that's really damn good, man.
And so another thing is we don't sell our Bitcoin. We hold our Bitcoin in our little treasury, and we only sell it if we have to.
Well, that's the whole point, people. If you start a business right now and you doing whatever, but you take Bitcoin for payment, you hold it, and you're also buying it yourself, you don't need to be cutting the quality of the business to make money, to scale, because Bitcoin will be that safe haven for you. And then eventually that will grow and appreciate and be your financial flexibility. So then we can actually have high quality businesses.
Right. One thing I've noticed, so since becoming a Bitcoin business, I'm very in tune with other Bitcoin businesses, and it's very hands down that if there's Bitcoiners making a business, you are going to receive a very high quality good. Bitcoiners don't do fiat things and make shitty products. I mean, obviously there's some out there, but the majority of Bitcoin businesses, you're going to get a high quality proof of work, based product.
Because who's going to give you Bitcoin for a shit product? Nobody.
Exactly.
I'm not willing to give any of my Bitcoin away if AUPA Bar was half the quality it is. But
exactly.
It's you're incentivized to make a good product, but then you have the financial flexibility if you're taking Bitcoin and saving it to be oh, well, I'm not going to blow up in a year or two, but give me 10 years and I'll have the financial ability to, invest way more back into the company.
Right. One of my favorite comments was we had I don't want to name any names, but a relatively popular Bitcoiner tell me, he said, I don't ever part with my Bitcoin. And really the only thing I've ever considered that has made me want to part with my Bitcoin is buying your bars. I was like, dang, that's a big compliment.
Yeah, it's not that big until he does it.
Yeah.
Bitcoiners, you need to spend your Bitcoin for companies that matter, right?
Right.
Like, I know it's worth it, right? Like, there's nothing. The biggest compliment is just giving you Bitcoin for AUPA Bar, because that's like,
even better.
I value your quality products so highly, and I want to support your business long term. Here's, my hard-earned sats.
Yeah. So before this business, I kind of had this Bitcoin mantra of like buy and hodl, right? That's the main theme. That's totally changed now. I am now a more spend and replace. If I can spend Bitcoin somewhere, I will do it and I'll replace that Bitcoin. So I have the same amount, right? Just take more fiat, you go mine fiat somewhere and get it, and then you buy more Bitcoin, you spend and replace. And that's how we get a lot of this stuff going. I mean, a lot of this whole thing about increased fees on the chain is a bummer, but I feel like Bitcoiners who really understand it are okay paying that $2, $3, $4 fee. It sucks, but this is the network that we're choosing to support.
There's always, there's a cost to transact. And I mean, that's only going to continue to go up over time.
Yeah.
And I agree. I mean, I've sold so many things for Bitcoin. I've bought a lot of things for Bitcoin, and I'm all for it, because it's just, so as someone who has sold things for Bitcoin, you know how much it means to get paid in Bitcoin.
Oh yeah. When we get a Bitcoin order, I literally,
and it's not that hard. Like, just go replace it. Like, I'm actually can get bad with that sometimes. Like, I'll pay a podcast editor in Bitcoin, and then I'm like, oh shit, I forgot to like replace that.
It, yeah.
So it's like, you got to be diligent on that. But it's the best way to do it.
Another thing I want to say is I see this theme all the time. Bitcoin or Lightning failed, it doesn't work, and all these things. And well, I can tell you directly from our customer base, it works. And we've settled hundreds of orders using Lightning, and it's fast and instantaneous. It's hard to get feedback. I don't know if there's been customers out here that have had a lot of technical difficulty with, but from my perspective, it works great. And then I actually did a survey. Well, I'm still small, or AUPA is still small in terms of social media. I did a poll on Twitter asking, do you use custodial wallets or self-hosted wallets when you pay with Lightning? And I think it was around like 80% of people use self-hosted wallets and 20% were custodial. And that's great. That's a great number.
It's cool to get that kind of data, because we really don't know, and there's not a lot of people doing this.
It was only like 16 or 20 votes, but that's not very statistically relevant, but it is what it is.
Rob, where can people find and buy the AUPA Bar?
Well, you can find AUPA Bar on eataupa.com. So it's EATAUPA. And you can just look at our homepage there and scroll through it, and you'll see a pretty good representation of what's in our bar. You'll get a really good sense of our ideals and our mission. Then obviously you just go to the product page and order whatever you want. A lot of people don't know what they're getting into, so they ordered the 3-bar sample pack. Each bar does have honey in it. Each bar has 1 teaspoon of honey. So it's pretty minimal. And you can find us on Twitter at EatAUPA. We don't really care how you say AUPA. We've heard 1,000 different ways, but the way we say it's a Basque word. It's AUPA. You can say it however you want. We don't really care. But spelling is AUPA. Yeah, follow us. We're kind of in stealth phase, I would say, right now. We haven't really done a lot of marketing. It's pretty much just us on our Twitter account. But we have plans to start growing over the next year.
I mean, I think it's going to blow up at some point. It's just like too good not to. I'm happy to be partnered, promote it. It's like, to me, one of the best discoveries, most convenient snacks, and based company behind it. You guys are awesome.
We set you at the promo code, right?
Yeah. Well, we have a couple now. I think it's D Radio for the podcast. Is it D Radio 5? I don't know. You can try D Radio or D Radio 5. And check it out. I love them, especially for hiking, skiing, hunting, camping, backpacking. I mean, you want like a caloric dense snack food. And that's like, I almost want to do an experiment this summer. I just go like 3-4 days in the mountains and only bring like AUPA bars and maybe
early explorers. It's a complete food. They
fishing rod
years on it.
Yeah.
So you can eat just solely pemmican or AUPA bars and survive. I mean, if you're tired of going down the grocery store aisle and you're just swamped by vegan bars that made from the same industrial sludge.
They all have like tapioca syrup or some nonsense in it. It's not real food. Like, it's crazy.
And then they get you and try to market with plant-based and vegan. Stay away from that stuff. Unfortunately, we're not in stores yet. We're only online. We do local pickup. So if you're around Longwell, we'd much prefer you come in here and show you the kitchen and stuff. And you can do a local pickup, avoid shipping. But many of you will be not local, so we do ship. But yeah, we plan on being in, once we get USDA certified, we can wholesale to, little mountain shops. We want to start with little tiny shops first. I don't want to get to a point where we're like selling bars at Safeway or Whole Foods. I don't want to be in Whole Foods. I want to be small but big.
Yeah, small but impactful.
Impactful.
I love it. Well, Rob, thanks so much for hosting me. Thanks for the chat. The EMF stuff, I mean, invaluable, right? There's almost nobody. I've talked to a lot of the engineers who do know about EMFs, and there's not a lot of us. So it's really great.
Like you said, the word nuance is a very nuanced topic, and it's very difficult. It's very complex. So, no one has just this direct answer for you.
Yeah. And for those who have bought my EMF 101 course, thank you. Rob will be appearing on my EMF 201 course, which is an even deeper dive into modern RF technology. And that'll be fun because, as you kind of got a taste here, it's very nuanced, very technical, but they're easy mitigation strategies. And that'll all be at decentralizedhealth.io. And thanks so much for coming on, Rob. We appreciate you, and it's been a blast.
All right. How great was Rob Rebich, former RF engineer, extremely based, living the decentralized lifestyle? There's very few people who I can geek out on EMFs with, because there's almost no engineers who understand that they are actually bad for our health. And there's very few people in the health space who understand electromagnetism. Now, if you enjoyed this conversation, you are going to love my EMF 201 course, which has a 2-hour cameo from Rob. So we dive even deeper into radio frequencies, into 5G, 6G. We even talk about military directed energy weapons, and it's really affordable. It's the most comprehensive electromagnetic education on the internet. You can go to decentralizedhealth.io/education and use code RF10 for a discount. If you are a health practitioner or really want to take control of your health, these courses are comprehensive, affordable, and I think imperative if you want to understand all aspects of optimal health. So check it out. And don't forget, 25% of proceeds goes to the Decentralized Health Fund to fund research.